Okay, welcome everybody. We'll go ahead and get started. Thanks for everyone for showing up for our March ISA New Orleans section meeting. Those of you here in the room and those of you online, appreciate you coming out. Okay, good deal. We always like to start the meeting with a thank you to all of our sponsors that sponsor the section. Sponsors pay $150 a year and gives them, we have a place on our website to show their logos and information about their company. And they also have the opportunity to kind of get first dibs on doing presentations. So we have Champion Technologies here today taking us up on that. And Joe Driver is back to do another presentation for us. He came in, if you remember, did the security presentation last year. He's going to talk today about virtualization. So we really appreciate Champion supporting us, and also Champion bought lunch for us today. So thank you to them for that as well. Just to give you an idea of what we have coming up in the next few months. So we have April 2nd, so first Tuesday next month. We have Greg McMillan coming in. Greg was a longtime Monsanto employee, works for Emerson. He's going to come in and talk about compressor surge modeling and control. He's in for another conference that's in town, and he's a good friend of the sections, good friend of Rogers, and said he would come in and do a presentation for us. So his presentations are always really good. So would encourage everyone to sign up for that one and attend here for that presentation. Then in May 7th, we're going to do a tour. Michelle Labs in Harahan is opening up their facility so we can do a lunch and tour of their facility. They're going to show us their calibration lab. They're going to talk about weighing technologies, some advances in weighing technologies, show us some demonstrations of products and technologies as well. So we're looking forward to that. And then that will be at their site. Both of these events are on our website now under the events section, so you can sign up for them already. And there are people already signing up to attend these events. On May 31st, we're going to be doing an exhibition and symposium at the Hilton Garden Inn by the Convention Center. So we'll have a tabletop exhibit area, and we'll probably have a couple speakers doing 1-hour presentations. I'm going to try to tap Paul Gruen to do a presentation, and maybe one other. So we have an opportunity there to get some PDHs and also an opportunity to do some look at some tabletop exhibits from different vendors. And then the next day, June 1st, is the District 7 Leadership Conference, and that's actually hosted here in New Orleans this year. So District 7 is comprised of Texas and Louisiana sections. There's, I think, 12, 13 sections between Texas and Louisiana. So this is the annual leadership conference for the district, and we're hosting it this year. So it'll also be at the Hilton Garden Inn, and it'll be on the Saturday, June 1st, all day. So anybody that's a member of the New Orleans section on the leadership team can attend. Any of you out there who would like to join our leadership team, we have plenty of opportunities. We're looking for a secretary. We're looking for a membership chair. We're always looking for any help we can get on various committees to put on events. So if you're interested in being part of the leadership team, kind of honing your leadership skills, please reach out to me. We'd be glad to add you to our team. And then another thing we're working on right now with Leo Hosenthal is we're cranking up the Control Systems Engineering PE Review course. That's probably going to start sometime maybe May, June timeframe, and it's going to run for about 10 to 12 weeks, an hour to an hour and a half session a week. And that's in prep for the PE course. The PE test is taught, I think it's given in October next year. So putting that together, we did that many years ago, real good success. So we're pulling that back together now. So just keep up to date with all this information on our event section on the website. I'm going to turn this over to Joe, but just real quick, just my 2 cents on virtualization, just because we see it a lot in my industry, who I work for. There's a lot of benefits with virtualization. The fact that instead of having to load up all these various PCs, now you can have PCs or servers and redundant configurations, and you can have all the operating systems and the applications all kind of encapsulated in their own little units. And so it's very easy to maintain that way. You're not as reliant as much on operating system support, for long term. You can hold on to an old operating system for a long time, patch updates, various things. So I don't want to steal any of Joe's thunder. I'm sure he's going to go into all this, but I just want to give my 2 cents that we see this a lot. I mean, there's a lot of work being done by the vendors putting together virtualized images of their systems so that those can be deployed on servers. And then, we see a lot of benefit as well with thin client technologies. So instead of having these fat PC-based clients, you have these zero administrative clients that you just give them an IP address pointing to a server, and they get all the data that they need to get, various screens and the things that need to be shared with them. So a lot of good benefits there. So with that, I'm going to turn it over to Joe.
All right. Hey, everybody. So my name is Joe Driver. I'm a corporate engineer for Champion Technology Services. We're a system integrator. Our headquarters is in Baton Rouge. As a corporate engineer, I kind of head up, we have a team within our company that focuses on what we like to call operational technology type services. And so, like we were saying before, we do a lot with cybersecurity, and virtualization is, we're seeing a lot of that. So I've been with Champion for 12 years now. This is basically the only company I've ever worked for, so straight out of school. And so I just really love all things automation. So I'll have Chris introduce himself.
My name's Chris Kuhlman, and like Joe, a corporate applications engineer. I'm a little new to this role. I've been in it a few months now. Been doing PLC, DCS work for the past 11 years with Champion, and getting more and more into OT technologies, network infrastructure, and of course, virtualization, providing those as a solution to our customers. So let go, Joe, and get started.
Yep. So this presentation is on virtualization and industrial automation. So just a little bit about Champion. So like I said before, we're a system integrator. We were founded in 2000. We have 8 offices. We're currently around 125 employees. Actually, I think we're a little bit bigger than that now. Project Reach. So even though we have these 8 offices, we've done project in pretty much all 48 contiguous states. Our core focus, really we pride ourselves on our technological excellence, and we're very customer focused. We kind of like to go above and beyond. A lot of companies will put in a new system or do an automation project, and they kind of just, okay, we've done our site acceptance test, we're done with it. But a lot of our repeat business is actually through the amount of service. We continually service. We do a lot of maintenance projects to continue the success of these systems we put in, and we help our customers achieve their goals as well. Our headquarters is based in Baton Rouge. We actually have 2 offices in Baton Rouge. One is the headquarters, and the other is a Baton Rouge automation office. And as you can see, we're kind of focused around the Gulf Coast area. We have a lot of offices in this area. And we also have offices in Colorado and Salt Lake City, Utah as well. So our mission, so basically what we strive to do is we really want to improve the safety, well-being, and prosperity. And, in the areas that we like to focus on are for our employees, our company, our customers, and our community. So we're always trying to do things to help out the community and our customers, and obviously our company employees as well. These are all the industries that we serve. Just due to being focused in the Gulf region, we kind of focus heavily on oil and gas, chemical, and transportation and storage. We're also recognized as an SI Giant, as a control engineering magazine for 5 consecutive years. So what is virtualization? So this is kind of the Wikipedia, generalized definition. Basically, it's saying virtualization is the act of creating something that's not actual, that is virtual. But really, what we're going to focus on for this is virtualization when it comes to computing. So you basically, what we do is we're creating a virtual computer that runs inside of another machine. And with that, you get virtual hardware, virtual network devices, virtual storage devices such as hard drives, and other resources as well. So there's different types of virtualization. So one type is desktop virtualization, and the software platform that would do that, just an example of one is VMware Workstation. So what this is an application that you would install on your PC, and within that application, you can run other computers. Our field service engineers love using virtualization just because, as Champion, we work with a lot of different vendor software. And as anybody who's tried to install a lot of different things on one computer, it's really difficult to get, your Rockwell software and your Siemens software both to run in the same environment. So we can create these little virtual workstations that each have their own individual environment, and they're not constantly eating up your resources because they're not always running at the same time. Also, another advantage is, as the slide before I come on, is some of the software also is, they require legacy operating systems. You would be very hard pressed to find a computer that can run Windows XP, a new computer right now. So we still have some software out there. I did some work on a Windows NT box just a couple of weeks ago, and unfortunately, it was still something critical to the plant. So I built a Windows NT VM, and I was able to, program their PLC and get them up and going again. So there's also server virtualization. So with server virtualization, there's different platforms for that. But really what that is that you have a machine whose only focus is to run other VMs. So you go and you buy this server box, and on that server box, it can run, it's just the limits of the resource. So you can run up to 15, 20 different VMs on this one physical box. So one of the things that's nice about that, especially in industrial automation, is, I guess, if anybody's ever noticed, these computers nowadays are extremely powerful, but most automation software doesn't require a lot of resources. We're not, doing huge complex calculations and not a lot of database transactions. So even your basic run-of-the-mill server is more hardware than you would need just to run one application. So what virtualization does is it lets you better leverage this hardware, your investment. So instead of running just one domain controller or one automation server, you can run, all of your HMI servers and your engineering station all in the same box, and better utilize all those resources instead of buying a separate computer and a separate box for everything. So it allows you to consolidate all these machines into one box in small collection. So those boxes, when you're talking about server virtualization, are called hosts. So that's your physical box. It's called a virtual host. You'll see us refer to that a lot. Another type is so virtual desktop infrastructure and application virtualization. So really what this is, so when you think about it, you have one physical box. It could be running multiple other machines. How do you access the individual machines on there? And so that's what you talk about, the virtual desktop infrastructure. And that's really just talking about a way to have, like I spoke earlier, you had thin clients or any sort of clients that could be networked. And it's really just a way for the users to interact with the VMs. How do they use the HMI that's on there, or the engineers, how do they use the engineering station and environment? But typically, the primary function and use that we see for that are with the HMI clients themselves. Another type of virtualization is containerization. We really don't see that a lot in the industrial automation world. But really what this is not only can you're virtualizing these computers, but really you can virtualize an application environment and package that together. So you can actually have this little sandbox of whatever application you want, and you can just deploy that, as a container. And there's different software platforms to allow that. So we wanted to talk about that. So as of right now, it is not widely used in industrial automation, but different manufacturers and software vendors are constantly innovating and coming out with new uses for all of this. So it may be something that we'd be seeing a lot in the next couple of years. Yeah.
I have seen that in industrial automation.
Okay, so there you go.
So one example is small panel software, 32-bit software. Symantec has a container, so you can build that to run that paneling software in the container. So you don't have to build an entire OS image. You can just run the application in its own little environment inside of whatever.
Yeah. And so, a lot of things, the reason why, we have this OT group is you're seeing this convergence between, the IT world and the industrial automation world, as we call the OT. And then hosted cloud computing. So I know right now when you think about industrial automation and cloud computing, just immediately I even mentioned that there's just red flags. I can see people's faces start turning, frowns. But a lot of the manufacturers are moving to cloud-based computing. Historians and data management servers running in the cloud. And I really, I'm fully bought in on cloud computing. I'm actually looking into ways within Champion for us to offload a lot of our computing resources to the cloud. It's mainly for the fact that I just really don't like dealing with hardware, which is kind of funny because I'm an electrical engineer, but it just becomes another thing that we have to worry about breaking, another thing we have to manage. So let's push this up to, to the clouds and allow them to, let them do all the work with worrying about upgrading hardware and all that stuff, and really just focus on the software and making sure that our environment is working the way that we want. So yeah, you're seeing a lot of push. So that's definitely, I'm seeing that in the next couple of years. You're gonna start hearing more and more about cloud computing with industrial automation. So this right here is just kind of a sample, a simple virtual environment architecture. Chris is going to talk about this a little bit more, but I just wanted to go over each of the main components. So this is a server-based virtual environment. So we had 3 hosts. So what this would be is 3 physical machines, 3 physical servers. And those servers would be running the VMs themselves. And then all these servers would have redundant connections to multiple switches. And then the switches would allow the servers to connect to, and I just put 3 sample networks, but it could be more networks, obviously. So you have the management network. So your management network is the network that you use to actually do your configuration, your deployment, make any sort of virtual hardware changes to the VMs. So that's really just your interface into the VM environment to make any changes there. Then you have your storage appliance. So really a storage appliance, that's really just a fancy word for network storage or any sort of storage array. So one of the advantages to this is, like I said, the VMs aren't tied to the host hardware themselves. So the storage appliance actually acts as the hard drive, the storage for all of these VMs. And it's not on typically you would not put these on the host. So you wouldn't use the storage within the servers themselves. You would have separate storage. And the reason for that is, let's say this host needed some maintenance. Well, what you could do is I could just turn this host off. And then if I have it configured, the VMs that were running in this host will move over to another host. And you can do that because their storage is independent of the hardware. So as you can see, it's really easy to make upgrades, hardware upgrades that way. So, and also you're not directly tied to your hardware with your operating system as well. So let's say you needed to expand, you can add another host, install the virtualization software on there, which takes about 15 minutes. And then you can split, evenly load share all your VMs between 4 hosts. And you can even, if they're critical virtual machines running in there, you can set them. So if something happens to the host, hard drive, well, I guess the hard drives are stored here, but if you had a power supply failure or any sort of hardware failure on that host, if it's a critical VM, you can have it so that VM will spin up on another host automatically. So as you can see, there's a lot of layers of redundancy you could build in here. And we're just using 3 computers, and this is a very small amount. You wouldn't use 3 computers to run 6 VMs. With this amount of servers, you could probably run 20 to 30 different VMs. So that can be an entire DCS, an entire control system. Pretty much every industrial control system related computer you can all be hosted on just 3 machines. And you have lots of layers of redundancy, and it lets your migrations and upgrades go a lot smoother. Because let's say I was running version 1.0 of my DCS software, and we really wanted to go to 2.0. Well, I could just build another VM on here, get it up and running, test it, make sure my network connections are great, and all I have to do is just hit really toggle this VM, turn it off, and flip the other one on. So it's really nice for staging your environments. You can actually stage your entire upgrade and your migration, and really just hit the switch when you're ready to go and have everything up and going already. And then finally is your process control. Yep, go ahead.
Is this reminiscent of the old X-terminal type and the server?
It is very similar to that, except for the main thing is, so X-terminal is like, it's a terminal client. So what you would do is you would have a client, a client machine connect to the terminal server, and then you would do all your computing that way. The thing about this is that X-terminal box not only is it hosting just one server, you can have multiple servers in there, but you would use a terminal type session to connect to them. It wouldn't be external. You could use something like remote desktop or Thin Manager or other applications for that way. But yeah, it's very similar to that type of computing where it's a server client based setup. Then you would have your, your process control network, which would just include, all of your devices on that. So these three networks can use, you have multiple switches, multiple connections. So there's a lot of redundancy built in, redundancies in your host, redundancy in your software if your software supports it, and then also redundancy in your networking. The storage appliances, they're a giant RAID array with multiple switches. If you lose a hard drive, you get an alarm, you just pull it out, stick a new hard drive in, and you never miss a beat. One thing too I wanted to focus on is because the VMs aren't tied to the host, and I said you can move between hosts, it actually does that completely transparent to the user. So you can migrate a VM from host 3 to host 2, and users on that VM wouldn't even notice that the computer, that they're originally running on had been shut off or moved at all. It's very seamless, and it's really surprising when you see it that you couldn't even tell. It doesn't even hiccup at all. So now I'm going to hand it over to Chris, and Chris is going to kind of discuss some of the benefits and the pros and cons of the virtualization environment.
All right, thank you, Joe. So driving factors of virtualization, why are we doing this? Well, number one, it's already been mentioned, fewer servers can run all your applications that may have taken 20, 30, 40 servers before on 3 servers in one rack. Which cuts down on your floor space, obviously. You might have a rack room that's got 10, 20 racks in it for a moderate size DCS. You can probably get down to 2 racks. Lowers your overall power consumption, which typically isn't a big driving factor for us until we have to start worrying about cooling that server room and buying several tons worth of AC for it. And another big thing is adding redundancy and improving recovery time. As Joe mentioned, you can seamlessly move VMs over. There are features within the different virtualization platforms to automatically restart VMs, and VMware even has a feature that allows you to run a VM on 2 physical servers simultaneously, so that if one server crashes, it is completely seamless to the user. So this allows us to recover from failures in minutes, not hours or days or longer sometimes. And then frequently this happens even without user intervention. So you might not see that anything has gone wrong until you walk into the server room or log into your management console and actually see that a server's failed. And finally, this increases your system flexibility. So you've got your support for legacy operating systems. You can spin up and shut down new VMs on a whim. You don't have to spend money on new hardware. If you want to do something in a test environment, really easy just to create a new VM, do your testing, shut it off, delete it, and no money was spent aside from your time on it. And this really does can ease upgrade and migration processes. There are options out there for not only recreating your machines in the virtual environment, reinstalling the OS from scratch, but there's also tools to convert physical boxes to VMs without having to go through a lengthy reinstall process and revalidating that everything is still working. So as you saw in Joe's drawing, a typical deployment, we use kind of as a baseline architecture. And I stole this from Dell. This is their wording. Called a 3-2-1 architecture, which is 3 hosts, 2 switches, and 1 storage appliance. And then you can see that over on the right-hand side, we've got the virtual machine sitting on top of the 3 hosts here, redundant network switches, and storage down there at the bottom. So the hosts, we want to size those so that if any host fails, the remaining hosts that are running can handle the entire workload. And typically the servers are powerful enough now that one server will be able to handle the entire workload. Switches, and anything networking, we need to have redundancy on it. So we'll typically do 2 stack switches for the core, such as a Cisco 3850, if you're familiar with those. 10 gigabit Ethernet to make sure we handle all the bandwidth that's going through there, because we've got multiple networks, not just your process network anymore. We're also talking about storage management. The vMotion requires network traffic to migrate VMs from server to server. So we want to make sure we take all that into consideration. And we'll typically aggregate or converge these links, bundle multiple 10 gigabit connections into a single logical link, and with multiple VLANs running over that. And that usually works fine. There's a few applications out there where that may cause issues. Seen issues with Siemens WinCC, for instance, and their engineering software not liking aggregated links. And then finally, to store all these VMs, we'll include one storage appliance. And this has redundancy built into the appliance. So as Joe mentioned, there's RAID for your disks. Now all the storage appliances out there will offer you RAID 10, RAID 5, RAID 6, whatever you prefer. But in addition to the disk redundancy, they also have storage processor redundancy, so that there's essentially a small server sitting on the back of these appliances that's handling the interface from the disks to your servers. And if one of those goes down, which has happened, the other one is able to take over seamlessly. And they typically run in an active-active configuration where they both can serve IO requests at the same time. Again, typically we've deployed this with iSCSI, in other words, over an Ethernet link. We've also done fiber channel interfaces for some customers that prefer that. And then to take advantage of the current storage technology and maximize our performance, we do want to use at least a hybrid flash array typically, which means that you've got some old school spinning hard drives and some newer SSDs that'll handle your frequently accessed data. And most of the storage arrays can present that seamlessly, so it looks like one logical drive to the end user. And of course, there's all flash options if you've got the budget for that, but those can get quite expensive.
At the beginning of the slide.
Yes.
At the beginning of the slide, did you say something about 321 Dell architecture? Is that what you said?
Yes, I got the terminology, the 321 architecture from Dell. I didn't come up with that on my own, but this is typically how we've deployed it, and kind of a base starting point for most systems. This where
Is that an architecture that they promote?
this is. You'll see it a lot as a kind of a basic reference architecture, both for in our market, the OT space, and also for what we call branch office or small business computing, where you might have a server rack in a closet. So there's a lot of applications that this kind of fits. Rockwell packages something similar as their IDC, and a lot of the other automation vendors will sell you this architecture. But, yeah. A few additional things to consider. UPSs, we do want to make sure we've got redundant power whenever we're doing this. It doesn't make sense to have all this redundancy if somebody unplugs one power cord from a wall and shuts everything down. So UPSs, you can get some very nice rack mount UPSs, or of course you've got your old high capacity UPS stacks and battery rooms. Just need to make sure we have some kind of UPS, and hopefully have it monitored so that we do know if something's gone wrong with it, or if it's failed over to UPS power. Firewall, of course. Cybersecurity is always a focus these days. So that'll typically be sitting between your management network, your process control network, and your business network. May require multiple levels of firewalls depending on your needs, and or even redundancy if you need high availability of data to the business. And when it comes to putting all this hardware in a rack, a common issue we run into is not buying enough cable management. So we do like to see the horizontal cable managers and also vertical cable managers going down the racks. If you're assembling this off-site, which is typically the case, racks are available from different companies that are rated for dynamic loading, which means you can stick it on the back of a truck and it won't fall apart on the way to your plant. And then a lot of these large switches, like again, I mentioned the Cisco 3850 series and similar switches, they're quite heavy. And if you just mount them by the front tabs, when you load it on a truck and start rolling it around, that weight of that switch will actually start making it sag. So you just need to take things like that into consideration when you're designing these, spend the extra money for the bracing and things like that. And of course, patch panels. Pretty much always we'll see fiber patch panels in a server rack. And for copper media, sometimes we go to the switches, sometimes we'll bring it through a patch panel. It does clean it up quite a bit to go through a patch panel. So rather than having to do a crimp-on RJ45 connector for every single wire you bring it in, you can bring it down to the punch-down blocks, which cleans it up, saves some install time, and you've got a little less chance of error there of somebody crossing some colors. So off of the server hardware on the clients, I'm sure you're all familiar with your classic thick clients. These would be your operator workstations where you have the client software installed on the machine. So this is typically what most people will stick with when you've got a pretty small set of operator stations and not a lot of different applications running on them. Everybody knows how to work on a Windows 10 machine, Windows 7 machine. It's easy enough to install the software if you've only got 10 of them sitting around. But once you start getting into larger and larger control rooms for serving multiple units in your plant, or even serving touch panels out in the field, that burden of maintaining all those, installing the software on them, replacing them when they go bad starts to grow and grow and grow. So if you've got 10, you might have to deal with them 2 or 3 times a year. If you've got 100 of them, you're working on them every week. So that's where we start seeing the thin and zero clients come into play. If you're not familiar, a thin client or zero client has a lightweight OS and not really any applications installed on it. For the thin client, it'll typically be Windows 10 IoT these days, because they're embedded Windows. Or for the zero client, it's not really any OS pre-installed, just the BIOS that runs on it, and it'll grab a operating system image from a Pixie boot server. Example of that would be Thin Manager. And with these, we're able to deliver mixed content to a single station. So if you want to deliver cameras and your operator station and your, say, your orders management system and SAP interface all on the same console for an operator to use, thin client technology allows you to do that. It allows you to partition that content, maintain your security, and still present it all in a single interface. It allows you to do user-targeted content delivery so that when different people log in, they have different applications that come up for them. quick replacement, obviously a big benefit with it. As mentioned earlier, you can typically change one out in a few minutes. Just set an IP address, plug it into the network, and it'll get its config, load the client displays, and away you go. You're not setting one up on your desk for 2 days, trying to get all the software installed, and then lug a 20, 30-pound machine out to the field to crawl under a desk and cable it up. So good option for video walls and control centers, big control centers, things with 10, 15, 20 workstations in a control room. If you got a video wall like this where you've got 30 monitors, there's clients out there now that'll support anywhere from 4 to, I've seen 7 from one vendor, all on a single thin client. That's 4K monitors. So, and if you're doing mobile options, which a lot of people are starting to ask for these days, maybe not leaving the plant, but people want an iPad or tablet they can walk around the plant on. This is gives you a way to get that data to the client without, in a more secure manner. So your control system data never gets transmitted to the client. It all stays on the server. Your client is just connecting that server and allowing the user to interact with it. So this keeps your data and your control system where you want it. Some of the challenges that we have with virtualization. So as I mentioned earlier, the redundancy is really nice because servers will fail and you won't even know about it. Unfortunately, that's kind of a problem because you might not know about it. So you do typically need to set up some type of alerting or at least have a practice to log in on a daily or at least a few times a week to make sure everything is still up and running. I've seen customer sites where we've got disk arrays with multiple disk failures in them and they're just chugging away. Everything's working fine. Seen hosts go down, nobody notices for a few weeks. So it's good, but you also, if you have another failure on there, that can put you in a real big bind because then suddenly you don't have anything at all anymore. So just need to make sure that everything is continuously monitored or as much as possible. Vendor support. That's kind of variable. Some vendors are completely open to it and you can do pretty much whatever you want. Others are a lot more locked down on their architecture. So big thing is just to follow the vendor recommendations and deploy them how they want, which can be a little bit of a challenge if you're trying to combine multiple systems into a single server. Maybe not multiple units, but at least different components of the same unit. So you've got utility PLCs and you want to combine those with the DCS system, the HMIs for those. So you got to make sure all your vendor criteria are met to make sure that everything works correctly. Otherwise, some funkiness can happen, especially when you have those server failures or try to do a vMotion and suddenly your HMI application crashes. And high cost of entry. And this is very variable. You can do this pretty affordably for entry-level systems. If you're just virtualizing a few servers, we can scale back from that 321 to just use a couple of hosts with local storage, or a couple of hosts in a storage array and directly attach the storage rather than doing 10 gigabit networking. And then on the upper end, scaling up to multiple data centers if you want to have a standby in a different area of your plant with a complete replica of everything in the first data center. That obviously immediately doubles your cost. And adding the hardware and extra compute required to deploy the virtual desktop infrastructure can start racking up the cost too. And a lot of fair bit of licensing costs with these as well, if you get into some of the more advanced feature sets. As mentioned earlier, there can be pretty good effort to convert your physical servers, but there's ways to get around that and convert your existing ones without having to recreate them. And then a lot of times the existing network really isn't up to snuff if you're trying to do a full deployment. So you might have to redo a significant portion of your core network to be able to get this installed. Few misconceptions. This will fix all of your problems. Unfortunately, it won't. It won't make up for a poor network architecture. Your normal maintenance tasks are still required. You still have to do backups, patching, and updates. Application and OS corruption can still happen. So if Windows gets corrupted and you don't have a backup, you're going to be reinstalling it and reinstalling your software. By its nature, it provides a means of disaster recovery. Not exactly. It enables easier disaster recovery than physical machines, as we've discussed. But again, VMs are just files. Those files can get corrupted. People can accidentally delete them. A lot of people try to use snapshots as backups. That's not their intended purpose. If any of y'all try to do that, we recommend using the replication or either Veeam or vSphere to replicate it to another storage location instead. And they're secure by nature. Again, no, your same practices, firewalling, patching, antivirus, you still need to do all that even though it's on a VM. We see a lot of people run VMs and VMware Workstation on their laptop that hasn't been updated in 5 years, doesn't have an antivirus installed on it. So not inherently bad, but just something to keep an eye on. You need to make sure that those at least get scanned periodically and nothing bad's on them, because those can, if you've got a service tech that gets a VM on his laptop, and in fact, even though he does a virus scan on his laptop, the laptop's clean, but the VM's not. And a lot of those VMs, because they're running legacy OSs, are more vulnerable and can transmit some of those older viruses that are still lingering out there. So that's just something to keep an eye out for. Any questions so far? Any questions? Or was that, yes?
Regarding licensing, is there different licensing for virtualized software versus regular? So like the field engineers could have 500 computers and just really want to run software every now and then. You have to have different licenses.
To an extent, yes. I can't go into all the Microsoft licensing because that's just a complete bear to try to deal with and make sense of. But with the newer OS licenses, typically you're allowed to run at a time 1 or 2 instances of VMs along with that physical machine. Windows 10, for instance. There's licensing associated with the virtualization software, VMware Workstation. I think list price on that's $250. So that's something you got to buy. And then once you get into your server virtualization, of course, there's a lot of licensing costs associated with that. Then they have different tiers that go from their Essentials kit all the way up to their enterprise licensing model, where you're paying for everything a la carte at a pretty good premium. For Windows Server licensing, typically you'd end up buying the Windows Data Center license, which is currently licensed by Core. I think that's new as of version 2016 or 2019. And So you pay for the cores on your physical server, and then you can run as many VMs as you want on that server. But all your servers have to be licensed by the number of cores they have. Will that work if you don't have all the licenses? Maybe, but don't let Microsoft find out. That's all I can say. I'm sure a lot of y'all will get audited by Microsoft from time to time. But yeah, as far as the desktop virtualization goes, I think, Joe, you've done a little bit with this.
So basically, Microsoft's really big in virtualization because it's an easy way to get more copies of Windows out there. So they basically give you two options. So if you just go to Best Buy and buy a computer, that Windows license, by default, I think they allow you to run, basically you can run the Windows license in there and one VM. So you get two instances at once. But if you go and buy like a enterprise Windows license, which is what I'm in the process of doing for all of our field service guys, you basically license to your entire machine, and you can run 5 instances at once, which is more than any of our field team would need. So you would have 5 VMs running at one time, and you can install it on as many VMs as you want.
So you could have 20 VMs on your laptop.
You got 20 on your laptop. Yeah, you can only run 5 at a time. Yeah, if you do with the basically the enterprise volume licensing. So we're working to making sure all of our field service team has that. And also with the server licensing, you get options as well. You can either license each individual VM of Windows Server on your host, or you could just license the entire box. And there's obviously a breaking point where it's, I think it's like at 8 VMs, it becomes more cost effective to basically license the machine versus licensing, each individual instance of Windows.
Right, and I think the current Windows Server licensing model is based off of cores on the physical host, whether you're doing what they call the Windows Standard license or the data center license. Just the standard license limits you to, I think, 2 VMs, and the data center lets you run unlimited, but it's still licensed by the cores on the host.
Yeah, that's just the new licensing model for Windows Server. They license you on the amount of processing power you have. When before it was the number of CPUs.
But I know as far as application software goes, some application software requires a license key. You can put that key on the host. Right?
Yeah, you can.
Your images back to that host.
Yeah.
So you buy with one key.
Yeah, so that's another nice thing too, is that you can plug things into your host, and then you can redirect that hardware to individual VMs. So some of the times we'll get some of the software that we use, especially software we use, and one of our engineers wants to use the key for that in their VM. So they just go in there and redirect it without taking it out and plugging it into something else, redirect that license or the USB flash drive they're using or whatever other USB device, and reconnect it to their VM, a logical connection. And the same thing can be done with networking too. I know we didn't really talk about it, but these virtual hosts have at least 4 network ports on there. The one that me and Chris were setting up for Baton Rouge today, we have 6. We use 2 of them a redundant link for storage, and then the other 4 are links to our development network. So our project engineers can do the development on it. So you can redirect VMs to different network. You could have each port connect to a different device or a different network. And with the click of a button, you could say, okay, we're now on this development network. Okay, now we need this VM to be on this network, or both of them at the same time. So it's really flexible, without pulling cables and moving things around. You actually create what is called virtual switches within the software. And everything's virtual. So you create virtual switches and virtual network cards and connect your VMs that way.
Yep. And speaking of the USB devices, if you do have client devices that are using those USB licenses, they're if you're using a thin client architecture, you can mirror the local USB connection over to the server so that you don't have to go plug in directly to the server. So that's another option for you.
Yeah.
But thankfully, most people are getting away from USB dongles for licenses.
But yeah, so one thing, one thing that we were really trying to, we do a lot of legacy migrations, in our industry. And one thing that we try to offer now is, there's a lot of downtime to go into a site and replace every single computer and then test everything to make sure it works. with these virtual environments, we could actually have, one server rack that has the entire control system on it. And we could stage that in our demo room, the entire DCS or control system there, and we can test everything out, wheel it into the plant, into the server room, and have it just sitting in standby. And it really expedites that migration process. We don't have to physically, you can't move the new hardware computers in there until the old ones get taken out. So, we're actually, we've done a lot of migrations, and I'll tell you the virtual migrations go a lot smoother just because we've had time to test everything out. Everything's installed. There's no surprises. Everything's been vetted and ready to go. When it's time to actually cut over, you're really just physically moving a couple of network cables over and reconnecting monitors.
And along those same lines, it also enables you to, for people to develop VMs offsite and then just bring them to the site on a portable hard drive or USB drive, load them onto your servers without having to install a whole new server, cable it up, find power for it. You're just copying files over to an existing server and power it on, and you're ready to go. So that really speeds up if you've got an existing infrastructure, minor cutovers and upgrades.
Yep. So, are there any other questions? Yep, go ahead.
In the past, when we talked about redundancy, we always worried about single failure. It looks like here, most likely the single point of failure could be power failure or air conditioning failure. Is that true?
Yeah. So what you try to, you always, you identify your risks and you try to mitigate those risks. So power failure risk, those hosts, you could buy those hosts with multiple power supplies in them. So you'd have one connected off of utility power, one connected off of UPS. And, air conditioning, you can actually have two data centers. We drew that drawing was done as if the hosts are all right in the same location, but you could put them in different physical locations as well, and that helps you with disaster recovery. If one of your server rooms floods or fire or whatever, you still have another, another location, another data center. So, it's really nice to be able to, you just have to identify what are your possible risks with your environment, and then there's ways to mitigate that.
So that's on the hardware side. What about on the cybersecurity side? Is that constant threat, this type of managed networking that you guys are talking about?
What the cybersecurity? So the main thing is that that we've seen for cybersecurity, the main risk there is that you're consolidating a lot of machines, and people like to just put like, oh, I have my historian, I'm going to put that on here. Oh, I have my SIS engineering station on here. And what you're doing is you're taking multiple security zones and you're consolidating them into one location. So you need to make sure, typically, a lot of, a lot of the strategy for cybersecurity is kind of like the defensive depth and segregation. So when you're doing that, you need to think, let's not try to have multiple security zones in the same box. It's a lot harder to protect and segregate two networks when they're on the same device. So, but obviously if things that you identify, if you're trying to segregate those, you may want to have a separate host that would put, okay, this is a higher security area, and, put a firewall between that. And make it a lot easier for to defend your network.
Yeah, and that's not to say you can't merge security zones onto a single server. You just have to identify whether or not you can tolerate the risks associated with that. But there are ways to partition those the networks on the servers. So you can allocate virtual switches to specific physical ports on the host. So you have everything for a certain set of VMs running through a single cable, or you can allocate them to specific VLANs, just depending on how you prefer to segregate your network and what your individual security requirements are. But it doesn't necessarily introduce any additional risk or by itself mitigate any security risk versus your traditional architecture. Having everything together is kind of a trade-off. It allows you to see everything in one location, which to me helps enable better security, because you're not having to manage 30 different switches in different places. Everything's in one spot, but really the key is just to be able to monitor everything and identify when anomalous events happen. So whether that be a security event or a hardware failure or whatever, just keep an eye on things and make sure that you know when things are going wrong.
Yeah, and and also the permissions that you can put in these virtual environments are pretty granular. As it almost becomes overwhelming. We've been dealing with that the past couple of weeks, to where we have that, certain people within our organization, if they log into the virtual environment, they have access to this host, but not that host, or they have access to these networks, but they can only connect to this network, but they can't make any configuration changes. And you can get down to every possible, permission. There's a laundry list of all the different permissions that you can assign, and you can set up users, permission levels and roles that way. So, security is definitely something that, we take in mind, and that we really want to focus on that. So make sure you have really good permission models set up, and, only give access to the things that people need, as opposed to just making everybody an admin that can do whatever they want, because then you run into issues where they could bypass, some of your security mitigations.
Questions online?
Yep. All right. Well, if anybody wants to, talk to us more, this is our contact information of joe.driver@champtechnology.com, chris.coolman@champtechnology.com. Well, we have a lot more virtualization type information on our website, champtechnology.com. I have business cards here if anybody wants to talk later as well. Always open to discuss, or even just come take a look at what your virtualization needs may be. Thank you.
Thanks for a great presentation.
Okay, well, thanks again for a great presentation from Joe and Chris, and thanks to Champion Technology Services for sponsoring this luncheon and the event. And so everybody, see you next April 2nd for our next meeting, and then after that for our plant tour at Michelle E. Scales. So just keep tabs on our website on the events list, and keep attending our events. Appreciate it. Thanks.